A big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast. In this podcast we cover topics such as engineering, artificial intelligence, neuroscience and other interesting topics to educate, inspire and engineer people's minds all around the world. I'm your host Jousef, and for this episode of the podcast I'm very excited to welcome Castillo to my show. Alex was a software engineer at Netflix and left to pursue his dream to build Neurosity. He is very passionate about the human brain and how we can use technology to understand it better. Alex has contributed to the open source community and focuses on Angular, React and NeuroTech. In his spare time, he likes experimenting with guitars and IoT. Neurosity is reimagining brain-computer interfaces and neuro-powered applications. Side note, this podcast was recorded in May 2020 and Neurosity already introduced the Notion tool for programmers. In this really interesting podcast, Alex and I talked about how to translate brain data, how to individualize the algorithm, privacy, and a lot of other interesting aspects. For updates on upcoming podcasts, projects and videos, make sure to follow me on Twitter as well as on Instagram. To join my weekly newsletter engineeredmind.sh where I share exclusive content, visit jousef.substack.com. And now, ladies and gentlemen, here's my podcast with Alex Castillo. Alex Castillo, it's a pleasure to have you on my podcast, and it's a very interesting one. So we didn't have something about BMIs before. And I want to start with a quote which I found from your TEDx talk, which says, "Imagine a world where you can just think about something and it happens. What a future would there be where your thoughts power the things around you? What things would benefit by understanding your thoughts and emotions?" Could you bring that into context on what you're working on?
Absolutely. Hi, my name is Alex Castillo. I'm a co-founder at Neurosity, and we believe in empowering the mind. And we believe that our brains are the most amazing thing ever, and that we shouldn't be limited by our bodies. So when I say imagine a world where you can just think about something and it happens, it's really about doing less with what we have, right? So we already have our brains, and our brains are controlling everything that our bodies do. What if we didn't have to translate certain things into movements in order to communicate with technology? What if you could trigger a computer command by thinking about it, right? So that is one of the things that we are accomplishing in Neurosity with reimagining brain-computer interfaces and making them as powerful as we possibly can.
Mm-hmm. So you founded the company, which is called Neurosity, with a co-founder, right?
Yes, with AJ Keller.
Mm-hmm. So what is the device called and how exactly does it work? Can you tell us a bit more about that?
Sure, I actually have it here.
Oh, so cool.
This device right here is called the Notion. And Notion is a brain computer that sits at the top of your head. So you could just stand it and then put it up here. And it reaches the regions of the brain that allow us to understand what kind of movement you are thinking about, as well as how do you feel, right? And how calm you are and how focused you are. Mm-hmm. And the way it works is that this technology is actually pretty ancient, I would say. It's almost 100 years old. The underlying technology is called EEG, and it starts with these sensors right here, and they image the brain 250 times every second. Mm-hmm. And I think today, right, if we think about this year, 2020, the advances that we've made when it comes to computer chips and artificial intelligence and hardware and the whole infrastructure that we have available in software, right? This is basically everything we're combining into a package that sits on top of your head. It actually is as powerful as a smartphone. So yes, it does have like RAM and CPUs and is connected to the internet. And this is what allows us to really do more with our thoughts.
Mm-hmm, get it. Can you call it a brain-machine interface? Because I think a lot of people associate brain-machine interfaces, short BMI, with what Neuralink does. Is it somehow comparable in some sense? I mean, you don't have wires in your brain.
Right. So brain-machine interface, right? It's regardless whether it's invasive or non-invasive. This is absolutely non-invasive, right? You can just put it on. You don't need surgery. But traditionally, this technology only has been able to acquire that signal, and then it can transfer that signal wirelessly to another device, whether it's a computer, right? So when you ask me, is it a brain-machine interface? I think it's actually a little more than that, because it's not an acquisition device. This is the first of its kind device that can measure and run some machine learning to understand you. And think about it as a computer that doesn't have a screen or a keyboard or a mouse, right? It just uses your brainwaves as the input. So it is absolutely a brain-computer interface, a brain-machine interface. We actually just call it a brain-computer.
So you're a software engineer, and what you get basically out from the interface, or what it recognizes, is a bunch of numbers, right? Millions of numbers. How does it work to translate this coding or encoding, however you want to call it, into something that's understandable and meaningful?
Right. So what it samples actually from the brain is the electrical activity produced by our neurons. And we have billions of neurons, right? So when these sensors make contact with the scalp, they are basically measuring networks, or large networks of neurons are activating. And this data comes as, like you say, just like numbers. In this example, just microvolts. And that's when really everything starts, after the hardware. And once you can get access to that electrical activity, what does that electrical activity really mean, right? What can those numbers tell us about ourselves? So that is when we go into research and neuroscience, and we start seeing what neuroscientists and researchers have been able to find as a correlation depending on where the signal is acquired and what type of frequency they map to. So we know that there are 5 major frequency bands. We know there's like alpha, beta, delta, and gamma. And they have been able to establish some type of correlation depending on which frequency we're actually reading. They have been able to use, for example, alpha as a way of measure like a meditative state or relaxation. So the more it increases, the more you are into that meditative state. Traditionally, you are not able to really measure how successful you are in meditation, right? But with something like this, it could tell you if what you're doing in your experiences, it actually correlates to a high level of meditation, and you can track progress because what you can measure, you can manage, and you can improve upon.
So obviously we are all individuals and everybody's different. Is it that you can somehow individualize the device so that the machine learning behind it, or the machine learning algorithm behind it, learns, so to speak, depending on the person?
Yes, everyone is different, like you say. And we actually share, give or take, like a third of our brain, or that part of the brain, right? And then after that, it basically everything that makes us unique. So yes, we are able to learn about each person because each person is different, and each person is basically, their device is learning from them and training a model that allows to understand what certain things mean specifically for them. One of the things that we do is, for example, we're able to imagine a movement. Just imagine like lifting your right arm. Even without doing it, we're able to detect that you're thinking about moving your right arm, but the way you imagine and recall moving thoughts of movement is different. And for example, let's just say that maybe you are into bowling, or you are into another sport, or you just play an instrument, and we have been wiring, of course, our bodies differently, and we have different parts of our body that have been trained more physically. So we do run the machine learning on the device to understand how you think of this specific movement, and we call this kinesis.
Got it. It's super interesting, Alex. What about background noise? Because when you have the device on your head, there's a lot of background noise from the environment and so on. Is it filtered?
Right. So we actually are, the range in which we produce electrical activity is in a very specific range, right? So there are many things that you can do when it comes to noise. A lot of the noise is going to be, let's say, past the 60 hertz, right? So we're able to like filter out those frequencies, and then we get more into like the human frequency where we get the most amount of information. And even after that, you need to make sure that you're purposefully blocking unwanted signals, right?
Mm-hmm.
And you can do that many ways. You can do that at the hardware level, and then you can also do denoising at the signal level. But there are always ways of trying to get the most amount of relevant information from the electrical signal that we are acquiring.
Mm-hmm, got it. I think it's what's also possible. I think you plan for that as well, and maybe you can let us know. Is that if there's any update, I mean, you can basically send the update directly to the device, right? And you're up to date.
Yeah. We run a full operating system on the device, actually based on Linux, and we are able to send over-the-air updates. I believe this device is the only one that can fully update like that.
Mm-hmm. Is it also that the device sends information back to you, to the company, and from that you can learn more about how to optimize the algorithms and so on? A little bit like Tesla, where they have the fleet, and the fleet basically collects all the images for Tesla and so on.
So privacy and security is something that we take very, very, very seriously, right? Mm-hmm. So one of the most important things that we need to think about today is that these EEG data, this electrical activity, can tell us certain things, right? It's not really like reading everything we're thinking. It can tell us like whether or not we're focused or calm, and they're like passive things, and maybe what you're thinking in the way of like how you move your train of thought. But this electrical activity, I think we're just the tip of the iceberg when it comes to understanding what it can mean. Mm-hmm. So the fact that we today don't know more than what we know, but we know something in the future we will know more. There was recent research on being able to use the same technology, being able to predict an epilepsy seizure up to 1 hour before it happens, right? Mm-hmm. And again, this technology has been around for a long time. So if we don't know that, we have to respect it, and we have to treat it as this is the most valuable type of information. So the first thing that we did was design the device so it measures the brain activity, but it sends metadata to the user if they want to use it, right? So that way we protect the most important part of this data as the raw data, right? And we send like, what is the score from 0 to 1 when it comes to the calm level, right? And that we do transmit to the applications that these users are using, because of course they need to be able to do something with this data, but we do not like store the data, right? Like this has to be treated like it's the most personal thing. Mm-hmm. So, and in that way, we're users of our own technology, and that's the way we want to be treated. So that's what we do for everyone else.
Mm-hmm. How is it if we are somehow in a diffuse thinking mode? Let's say I'm thinking of scrolling my iPad, as we saw in one of your beautiful videos, and in the other moment, I'm thinking about something completely different. How does the device react to it?
Yeah, so there's this concept about context, right? Let's say you use maybe the same finger to play a song on your phone, and then sometimes you use the same type of gesture, the same tap to scroll down on some of the website or some of the application, right? These are basically gestures and commands. But what changes, right, even if you tap the same part of the screen, is just the context behind it and what you can see, right? So that is an area that we're going to have to be exploring a lot when it comes to context. So right now, it doesn't know that you are looking at that iPad at that moment, right? It does know that type of thought is mapped to that application running on that iPad that can allow it to scroll. So I believe that there's something that we can do about switching the context, so you can maybe reuse the type of trained thoughts that you have. Mm-hmm. But something that we're really interested in working very hard to do right now is to make programmers more efficient. So right now we've been using it to develop this platform ourselves, and we noticed that there is a moment when coding, right, is actually not productive, right? There's a time where you're very tired, and we wanted to understand if the time that we're investing into building and coding is actually something that is worth putting. So we started by quantifying our productivity when we code, and we realized that there's a lot of people that can benefit from this, right? There are 23 million programmers, and this is growing massively year over year. So one of our first applications allows programmers to be more productive, and it quantifies their productivity as they code.
Mm-hmm. Would be also super cool if you had something like a browser app or something like that, or software which actually tracks your states, your mental states. Is it in production or like in planning?
We do have applications in production. We shipped 60 of these units last year, and we have people using it. Some of them have developed a habit where they use it every day to be able to quantify their work and their productivity. So right now, our goal is to be able to, again, empower people's lives, right? Right now, specifically programmers, to be able to have more of those like magical moments when they get things working, right? Because they are able to get into that flow state where their code is very productive and it's going to yield good results because you're not tired, or fatigued from working so many hours during the day.
Mm-hmm, got it. When will we be able to get the device? I think around December 2020. Is that right?
We were talking. We have been able to do that a little bit faster than that. So we're shooting right now for early fall. We are very respectful of what timelines we commit to. Last year, we had promised our users that we were going to ship December 31st. We shipped December 30th. And right now we're shooting to do early fall and have this in people's hands, as soon as possible. And we do have the pre-order on our website, so you could go and pre-order your device today.
So cool. I'll link everything down in the description. Is there anything else users or the audience should know about the company or maybe the device in general?
At the personal level, I would say that working on this, I've grown so much, because if you think of the challenges of pulling something up like this, right? You need to start by understanding, let's say, even the anatomy of the human head, and create something that can fit everyone's head and that can understand certain parts of everyone. So this is useful to every single person out there. On the engineering side, I've been a software engineer for over 15 years, and I had the chance to work at amazing companies here in New York and Silicon Valley. I worked for Grubhub, New York. I worked for Netflix in Silicon Valley. And at some point, once you build applications, you kind of want to try to build even better applications, right? But we have gotten used to using the computer the same way. We keep using the keyboard that was designed so many decades ago, right? We keep using our hands to be able to translate what is inside our minds so a computer can understand it. So what if we flip the whole thing and we have computers learn from us, so we don't have to basically be moving our bodies and our hands at all times to do the same things, right? What if we could just have a more direct communication with technology, and maybe have technology do things for us when we know we cannot do them, but it knows that that's what you want. So the whole beauty behind neurotechnology is that we can offload less work on the user side and have a computer directly communicating with their brain so they can be more human, right? One of the things that I'm really optimistic and excited about is also changing how we experience applications, right? And games and content, whether you're watching Netflix or you're playing a video game, right? Let's just take, for example, the video game. Video games today only know what you're doing with the controller, right? But what if they could just know, even if you were not engaging with the game, or you were not focused on it, right? Maybe you could pivot the whole story to make it to work for you, right? Everyone is unique, but we keep building the same experiences, assuming it's gonna make everyone feel the same things. But we have this opportunity to create more customize and more personalized experiences at every level of our lives, whether we're using a website, whether we're using a mobile application, whether we're watching Netflix and maybe we want something to help us know what is the next title we want to watch, or maybe if it's a choose your own adventure, it can make those decisions for you because it's measuring exactly how you're feeling in real time. Mm-hmm. So this is one of the things that we see as a very, very bright future that is ahead of us, is having experiences be tailored specifically to us as individuals.
Mm-hmm. What I also saw is that you have a developer kind of program or like use case. So developers would be able to play around with the device. Is that correct?
Yeah. Some of our users buy the device just so they can build their own applications. We have some developers that have built many amazing applications in that they use our API to tap into their own data. And one of our users actually recently was able to launch his own application that he deployed to Android, to the Google Play, and to the App Store. So he basically came up with this idea that maybe when he's driving, right, he wants to use his phone as a way to ensure that he's not losing focus. So he would wear the device, right, and the device would basically give him feedback. This is actually called neurofeedback. If your focus drops a certain threshold, maybe you just get like a little sound or some type of feedback that allows you to get back on track, right? And the possibilities are just endless, right? There are users that are interested in building experiences to understand more why, how like ADHD changes them and how taking different medications changes them. Mm-hmm. Users interested in understanding more on like how we sleep, right? And how our brainwaves are affected when we get tired. So there are a lot of things that developers can do when they want to build better applications that don't rely on keystrokes or just clicks and taps, because we're actually clicking, tapping, right? Thousands and thousands of times a day. The average person that uses their computer on a daily basis is pushing buttons around 10,000 times a day. I mean, think about that. That is just insane. And we just gotten used to it. That's just the way things are. That's the status quo. But it doesn't have to be that way, right? We didn't have to drive cars. We had horses. But, there's something to be said about pushing, humanity forward with the technology that we have available at our hands today.
Mm-hmm. That sounds super interesting. And I'm really looking forward to see maybe the device. I'm getting one, hopefully myself, and maybe test it on the channel, and people can think if they want to get one for themselves.
That would be cool.
Yeah. So to wrap things up, I'll put every link down to Neurosity and the device and so on, and relevant links down in the description. If people want to reach out to you, where can they do that? On Twitter?
Sure. Yeah, I'm pretty active on Twitter.
Mm-hmm. That sounds amazing. Okay, cool. Thank you so much, Alex, for your time for this podcast, and hopefully we'll do a second part if you release more interesting applications in the future.
Absolutely. Thank you so much for having me, Jousef. It's been an honor, and I look forward to continue the conversation, whether it's online or offline someday.
Thank you so much.